Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Affiq.The bin Muhammad Hanif. We are from LO1 and we have decided to choose topic for this mini project, which is Bernoulli principle in industries. For our group, there will have 4 presenters including me. The first presenter is Athirah Ayu binti Muhammad Shahrizan. The second is Nur Sahfiqah binti Azmi. Third one is Hawa Zahirah binti Rashidi, and last presenter is me. For this presentation, there are 5 elements that we will be explain, which are introduction, application, theory, impact, and conclusion. So please allow our first presenter for today, Athirah Ayu.
Thank you, Muhammad Afiq. Bismillahirrahmanirrahim. I am Athirah Ayunajiha, the first presenter for today, and for my part, I'll be explaining about the introduction of Bernoulli's principle. As you can see in the slide, it says that Daniel Bernoulli first published hydrodynamica book in 1738, and we know that Bernoulli's principle can be applied to various types of fluid flow, resulting in a various term of Bernoulli equation. And lastly, Bernoulli principle can also be derived from the principle of conservation of energy and also Isaac Newton's second law of motion. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Nur Sahfiqah Azmi and I will present to you about theory. So, Bernoulli's principle is essentially our energy conservation principle, which states that an ideal fluid or flow situations where effect of viscosity are neglected, with no work being performed on the fluid, the total energy is constant. The pressure, speed, and height at 2 points in a steady flowing, non-viscous, incompressible fluid are related by the equation below. This equation is the sum of the kinetic energy, potential energy, and gravitational energy at height. If the equation was multiplied through by the volume, the density can be replaced by mass, and the pressure replaced by force times distance. As the replacement, we can see that difference in pressure does work, which can be used to change the kinetic energy and the potential energy of the fluid for this equation. So next, equation for continuity. The continuity equation of continuity states that for an incompressible fluid flowing in a tube of varying cross-section, the mass flow rate is the same everywhere in the tube. The equation of continuity can be written as rho 1 A1 V1 equal to rho 2 A2 V2, which is rho for density, A cross-sectional area, and also V for velocity. The density stays at the constant, and then it is simply the flow rate AV that is constant. The velocity of fluid is greater in the narrow section as we apply the continuity equation. So, Bernoulli's principle also states that if a non-viscous flow along a pipe of varying cross-section, then an increment in the speed of the fluid simultaneously with a drop in pressure or a decrease in the fluid's potential energy, and the pressure increase when the pipe opens out and the fluid stagnates. Thus, pressure will decrease when the velocity increases. This is expressed with the following equation. Rho P over rho G plus V power of 2 over 2G plus Z equal to H star, which is constant. So, P for fluid static pressure at the cross section, rho for density of the flowing fluid, G for acceleration due to gravity, V mean velocity of fluid flow at the cross section, Z elevation head of the center at the cross section with respect to a datum, and also H star equal to total stagnation head. Thank you.
Hi, my name is Hawa Zahirah and I will explain about application of Bernoulli principle. The first application of Bernoulli principle is venturimeter. Venturimeter is used to measure flow rate through tube. And based on the use of venturi effect, the reduction of fluid pressure that results when a fluid runs through a constricted section of pipe. The second application is the Laval nozzle. The Laval nozzle is the tube that is pinched in the middle, making a carefully balanced, asymmetric hourglass shape. Nice platform to highlight the differences introduced by the compressibility of a gas. And the last application is airflow. Aeroplane can fly because of the pressure difference between the flow below the wing and the flow over the wing. This results in a lift force that opposes the weight of the plane. Thank you.
Thank you, Hawa Zahira. Next, I'll be explaining about the impact of Bernoulli principle. So the first impact is when Bernoulli principle is applied, it is valid for any fluid. Then we need to know that it is very important to fluids moving at a high velocity. And lastly, when Bernoulli principle is applied, the impact is Bernoulli principle exists. It states that for an ideal fluid such as air on which no external work is performed. Thank you.
Thank you, Ayu. So lastly is about the conclusions. Bernoulli principle is very important in many things. The Bernoulli principle features a wide selection of applications in engineering fluid dynamics, from aerospace wing design to designing pipes for hydroelectric plants. For instance, within the case of hydroelectric plant that utilize water with mountain reservoir, knowing the elevation change from the reservoir within the mountain to the plant in town helps engineers to determine how briskly the water are going to be flowing through the energy generating turbines within the plant. So that is for conclusion of Bernoulli principle. So thank you.